On this RAM 1500 with the 3.6 Pentastar, P0138 means the PCM is seeing the downstream oxygen sensor signal on sensor 1/2 higher than expected. The MIL may be on, and depending on how the fault is acting, the truck can run normally or may show fuel control-related symptoms. Broadly, this can involve the O2 signal circuit, the return circuit, heater control, sensor ground, the sensor itself, connector problems, or in the end, the PCM. If other codes are present, check what they mean first so you are not chasing a symptom from another fault. Then start with the basic system checks and follow a structured diagnostic approach. First, confirm whether the condition is active. This code sets when the PCM sees oxygen sensor 1/2 signal voltage greater than 20 volts. Start the engine and let it idle for at least 60 seconds. Stay clear of the fan, belts, pulleys, and loose clothing while the engine is running. On the scan tool, watch the O2 sensor 1/2 signal voltage. The normal O2 sensor output is a 0 to 10 volt analog to digital signal, with a possible negative offset up to -10 volt, and the bias signal should switch between 2, 5 and 3, 5 volts. For this path, the question is whether the signal is staying above 40 volts. If it is, keep going. If it is not staying above 40 volts, treat it as an intermittent condition and reproduce the captured conditions instead of forcing the rest of this chart. Next, look at O2 sensor 1/2 heater operation. Watch the heater duty cycle and compare the heater temperature to the other O2 sensor heaters. A normal switching heater duty cycle typically ranges between approximately 30 and 50%, and typical heater temperature ranges between approximately 1200 degrees F and 1400 degrees F on the scan tool. If the PCM disables the heater driver, the duty cycle will be 0%, and the bias signal voltage can read high, usually staying above 40 volts. Even small heater circuit resistance matters here. 3-4 ohms may not set a heater control code. 4.050 ohms can raise the scan tool heater temperature by as much as 700 degrees F, and as little as 2.0 ohms can raise it approximately 250 degrees F. If heater operation looks correct, skip ahead to the signal circuit short to voltage check. If heater operation does not look correct, test the heater side circuits first. If the heater side failed the comparison, start with the O2 sensor 1/2 ground circuit. Disconnect the component connector to isolate the ground circuit, connect the load test tool positive lead to battery positive, and connect the negative lead to the ground circuit at the component connector. Use a proper load. A 3156 bulb has approximately 6.0 ohms of resistance when powered and draws approximately 2.0 amps. Many high-impedance test lights draw less than 0.1 amps, so the tool used for this load test should draw more than approximately 0.75 amps. The bulb should be illuminated and bright. If it is not, repair the ground circuit for an open or high resistance, then verify the repair and confirm the code stays gone. If the ground passes, isolate the O2 sensor 1/2 heater control circuit. With the ignition off, disconnect the ECU and every component connector that contains that circuit, while leaving inline connectors connected. Check for continuity between the heater control circuit and the other circuits at the ECU connector. Do not probe the PCM harness terminals directly. Use the GPEC Diagnostic Adapter 10436 when probing at the PCM connector is necessary. With the circuit isolated, there should be no continuity to any other circuit. If there is continuity, repair the short between the circuits that have continuity, using the wiring diagram to isolate the location, then verify the repair and confirm the code stays gone. If the heater control circuit is not shorted to another circuit, check it for a short to ground. Keep the circuit isolated with the ignition off. Connect the DVOM negative lead to a known good ground and probe the circuit at the component connector. There should be no continuity between that circuit and ground. If there is continuity, repair the short to ground, then verify the repair and confirm the code stays gone. If it passes, load test the heater control circuit for open or high resistance. Keep the ECU and component connectors disconnected. Do not load test any circuit with components still connected. Connect the load tool to battery positive. Connect the other side to the circuit at one component connector. Then use an approved back probe tool and fused jumper wire to connect the other end of the circuit to battery negative or a known good ground. The bulb should be illuminated and bright. If it is not, repair the circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If it passes, move to the sensor replacement and retest step later in the path. Now check the O2 sensor 1/2 signal circuit. Turn the ignition off, disconnect the sensor connector, turn the ignition on and measure the signal circuit voltage at the component connector. A 5-0-volt signal or reference circuit should be between approximately 4, 8 and 5, 2 volts. If this circuit is above 5, 2 volts, repair the signal circuit for a short to voltage, then verify the repair and confirm the code stays gone. If it is not above 5, 2 volts, isolate the signal circuit for an open or high resistance. With the ignition off, disconnect the ECU and the component connector. Before measuring circuit resistance, measure the resistance between the two DVOM leads because the leads can add resistance. Then measure the signal circuit end to end through the proper adapter when needed. The resistance should be below 3.0 ohms. The GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit, so keep that in mind when reading the meter. If the signal circuit is not below 3.0 ohms, repair it for an open or high resistance and verify the repair. If it passes, perform the same open or high resistance check on the O2 sensor 1/2 return circuit. That circuit also should be below 3.0 ohms. If it is not, repair the return circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If the heater control path, signal circuit and return circuit all check out in order, replace O2 sensor 1/2 and retest. Reconnect the O2 sensor 1/2 and PCM connectors, turn the ignition on, erase the codes, and operate the vehicle under the captured and monitored conditions that set the code. This monitor runs continuously with the engine running, and battery voltage needs to be between 11.0 volts and 15.8 volts. Then read codes again. If P0138 does not return, the sensor replacement repaired the fault. Verify the repair and confirm the code stays gone. If P0138 does return, move into connection checks. Address any applicable bulletins, disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Inspect connector fit, locks, corrosion, water intrusion, weather seals, bent or pushed back terminals, spread terminals, terminal tension, and signs of overheating from poor connection. Repair any condition found, reconnect everything fully, erase the codes, and operate the vehicle under the monitored and set conditions again. If the code does not return, the wiring or poor connection problem has been repaired. If P0138 still returns after the sensor retest and the related connection checks, the remaining directed repair is to replace and program the PCM, then verify the repair and confirm the code stays gone. The key is to stay in order. Confirm the high signal, separate heater influence from signal circuit faults. Load test the circuits instead of relying on weak test lights, and only move to sensor or PCM decisions after the circuit checks support it. For more diagnostic training, visit stepdiagnostics.com.